Hi, my name's Jessica. I'm a graduate student at the University of Wyoming studying astronomy, specifically looking at how galaxies form stars. Sorry, my kitty's talking a little bit too, if you hear him. But today I wanted to do an activity where we make a universe out of a balloon so we can see how astronomers might measure universal expansion and what that kind of looks like. So what you're going to need to do this is you're going to need your balloon universe. You're going to need some Sharpies or some sort of pen that you can draw on your balloon with. You really only need one. I just have a lot in the dork. And then you're going to need some sort of measuring tool. I have a tape measure. It's going to be helpful for you if this is kind of a flexible thing because we're going to be measuring on our balloon. We're also going to need a little note keeper that we'll be using as we go. So that's about it, and we can go ahead and get started. So the first thing we want to do is we want to take our balloon, and probably near the top we're going to draw a galaxy that's going to be our galaxy, so the Milky Way. So I'm going to start just by drawing a little galaxy, and it's good if you can kind of label these so you can keep track of which things you're drawing. So this one, I'm drawing a little galaxy, and I'm going to label it MW for Milky Way because that's our galaxy. So you can see on there we've got a little Milky Way galaxy near the top. And now you can kind of do whatever you want with your universe. So you can draw some more galaxies, you can draw some planets, you can draw some stars, but just make sure you draw quite a few, and you can make sure you can tell them apart somehow. So maybe that means labeling them, like I labeled the Milky Way. Maybe that means using different colors, but we need to be able to tell them apart. So I'm just going to do a couple here. I did this earlier, so I'm going to kind of rush through it, but you guys should take your time and maybe pause this video so you can draw a lot of things for your universe. I'd say you want at least 5 or 6 so we can get a good sample size. But I'm just going to draw a couple. So I have my Milky Way, and then we can see there's a star, a little funky star, and a galaxy on there as well. So I have my Milky Way and a star and a galaxy. So that's step one. So this is going to be our pre-inflated universe. So this is like the universe back at the Big Bang we might think of before expansion starts to happen. So the next step, what we want to do is we want to take our tape measure, and we're going to measure all the distances from the Milky Way to each object. So this can be a little tricky, just do your best. This is all just kind of for fun. We want to practice taking our measurements. So we want to put one end, your 0 end, right up at your Milky Way, and then pull down to your objects. So for my first one, let's see if I can get this without it disappearing into my background. My first object, it's about 3 centimeters from my Milky Way to my star. So that's what I'm going to put down. I have like a little list. Sorry, I guess you guys are seeing this backwards, but I want to put down for my first object is a star. And it's going to start 3 centimeters away from my Milky Way galaxy. So what I've recorded there is my object, which is the star, and then the initial distance from the Milky Way, or whatever you set for yourself kind of at the top. And then I haven't filled in this final distance yet because I don't know what that is yet. So I'm going to do that for all of my objects. I'll get my galaxy 2. Oh, maybe about 2.5. So you want your things to be slightly different distances. So if all of your things are kind of looking like they're the same distance, you might want to add a few more. So this could be another time. So I just did 2, like I said, but you probably want to do more than that. So this might be a good time to pause this video, take a second to make all those measurements and fill out your chart. I did another balloon earlier, and what you can see is I did a bunch of objects and they were all sort of different distances. So I'll show you guys that one in a second. So once you've done that, you're going to blow up your galaxy. So this is like expansion. If you've ever heard that the universe is expanding, that's what we're going to do now. We're going to expand our universe. So we're going to blow it up. You might need a parent to help you with this, or you can do it yourself. So now our universe has expanded and those distances have changed. You want to tie it off. See how quickly I can do this. Now we have an expanded universe balloon. We still got our Milky Way, I can still tell what that is, and then also my other objects I can see where they are too. So now I want to take my measuring tape again, and I'm going to find their final distances from the Milky Way. Again, putting one end on the star and one end on the Milky Way. We can see the star is now about 10 centimeters. And my galaxy, so I'm going to mark that down. The universe is going to fly away. We don't want that. So in my final distance column, I'm going to mark 10 centimeters for my star. So it looks like that. I'm going to do the same thing for my galaxy. My measuring tape. Okay. So one end on the galaxy, one end on the Milky Way, and it looks like it's about 7.5 centimeters. So I'm using centimeters. You can use whatever unit you want, as long as you're consistent. That's the most important thing. So there we go. I have my whole thing filled out. This might be another time you could pause this video so you could fill out your own sheet. So you can get all your measurements. You should have more than two. I'm just, like I said, I'm just doing two for now. But when I did this earlier, I did a whole bunch. And so we can look at that guy over here. So this is my final blown up universe for the one I actually did a bunch of things. We got like a Saturn, stars, we got some galaxies. I made a little sun, I made a little UFO. I'm not the best artist. The important thing is, again, that you can tell them apart. So like I put numbers by all my galaxies. So this is galaxy 1, this is galaxy 2. I think we got galaxy 3 over here. And I did my stars different colors so I could find them again. And I have the Milky Way right at the top. So this was my expanded thing, my expanded balloon universe. And the final thing we want to do is we want to graph all of our points. So the way we make a graph, so I've done it, oops, there we go. I've done it down here. Sorry, this is going to be kind of reverse again. Maybe we can flip it. But we want the initial distance on our x-axis, so that first measurement you made on the x-axis, and the final distance on the y-axis. So again, so for like my star, I would start out at 3, then I would go up to 10, and I'd make a spot right there, make a point right at 3 and 10. You could also do this using Excel or Google Sheets if you wanted to use a code, a program, instead of doing it by hand. It makes it a little better, but I just did it by hand. So I did it for all of my points here. Oh. We can see, with a few exceptions, I also kind of connected them with a line the best I could. So this is my line of best fit. And what we can see is that ones that started closer ended up closer too, which is probably what you expect. But it's not that each galaxy, you know, if I started at 2, I didn't just add 4 centimeters, because then we would see them all moving up the same amount. And it wouldn't necessarily look like a nice linear relation. What we're seeing is the further away you are, the further you had to move. So if you started really far away, something that started about 6 centimeters away ended up about 24 centimeters away. So it had to move a lot. Whereas something that was 2 centimeters only ended up around somewhere between 6 and 8 centimeters away. So we're kind of seeing that there's like a multiplicative factor. Instead of with adding a distance, all of these distances are getting multiplied around by a factor of 4. And that's probably, if I measured the slope, that's what I would see. And that's my expansion rate for my universe, is the slope of this line. How fast it's going. So in the time it took me to blow it up, my universe got 4 times bigger. And that's kind of what's happening in space. So let me grab my pink universe balloon. What we see in space is that all of the galaxies we can see, with a few exceptions of ones that are really, really close, are moving away from us. And ones that are further away from us are moving faster. And what that tells us is that it's not actually the galaxies themselves that are moving. None of our objects on our balloon actually changed location. What happened was our balloon changed size. So the universe itself is expanding. Space is expanding. The space-time fabric, the stuff between the galaxies, is what's expanding. Because of that, if there's more stuff, if there was more balloon between my Milky Way point and one of my galaxies or my star or my planets, then there was more stuff to expand. So it moved further than the ones that were close. The other way I like to think about this is like maybe you guys have been doing some baking. Maybe you made like chocolate chip banana bread or something. All your chocolate chips, they started out really close to each other. But as your banana bread, as you baked it, as it got bigger, the dough kind of stuff got bigger. Also, all the chocolate chips moved away from each other. So our dough is kind of like our universe or space, and the chocolate chips are going to be kind of like our galaxies. So that's also what's happening with your universe balloon. And why this is really important for astronomers is that we actually use this to measure how far away different galaxies are. So when I'm looking at really distant galaxies, one way I can figure out how far away they are is I can look at how fast they seem to be moving. And I can use that to figure out how distant they are from our galaxy, because the more distant ones will look like they're moving faster. So behind me, what I've got going on, this is the Hubble Ultra Deep Field. This is the Hubble, I think it's the Hubble Ultra Deep Field. Sorry, there's an Extreme Deep Field as well, and I can't remember exactly which one. But each of the spots behind me then pretty much is a galaxy. There's a few exceptions. This guy right here, that's a star. We can tell because it has those diffraction spikes. But any of those fuzzy blobs are galaxies, and we can look at how fast they're moving away. That's a measurement we can make pretty easily. And then we can use that to figure out how far away they are. The other thing that's really cool is all these green squares that show up. This one over here, this guy, 22. They correspond to things on this side. So those are galaxies that are hard to see in the image, but with computer programs, the astronomers were able to pull out these really red, splotchy galaxies that are very, very, very distant. So some of these are over 10 billion light years away, and they're some of the most distant things that we've seen. But we figure out those distances by looking at how fast they're moving. So just like we did as we made our graph, astronomers can say, okay, they can figure out how fast they're moving, and they can use that to figure out how far away they are. So we just expanded a universe with our balloon, and what we saw was that it wasn't the galaxies that were moving, it was the universe balloon that was expanding. And as that expanded, the more distant you were, the faster it was you were moving in that same time of me blowing air into my universe balloon. So that's a little bit about how astronomers can measure universal expansion, and then also use that universal expansion to measure distances to really distant objects like galaxies. I hope you enjoyed this little science experiment, and maybe now you can have play around with your universe balloon, toss it around or something. Thanks for joining me, and have a great rest of your day. Bye.